All right, so if we want to draw the number of ions that result when I get aluminum sulfate and put it into solution, so we watch it dissociate, all right? There's aluminum ions, there's sulfate ions. I look on the back of my periodic table and I see the sulfate ion, right? The sulfate ion is a -2 charge, okay? So there's a -2 charge. I see that there's 3 of them, so I put a 3 up there to show that I had 3 of the sulfate ions. After I see that it's a -2 charge, I can also see that this aluminum, because there was 3 of them, must have been a +3 charge. All right. Also, I can use the periodic table to see that it's a +3 charge, right? Bring the periodic table over here. Aluminum is right here. +1, +2, +3 to become like neon. Okay. So I have to also make sure I have 2 aluminums. All right. And so that is the ions that result when this is placed into water and dissociates. Okay? All right, the next one. You try the next 2 on your own. All right, take a few minutes and try them. Push pause, give them a shot. All right, hopefully you stopped and did them. I'm going to show them to you now. So hopefully you got them right. Notice how on this one there's 2 chloride ions like that. Very important. The 2 goes in front, Cl-. 2 permanganate ions, MnO4-. You look in your polyatomic ion chart there. You have our permanganate ions. Okay, very good. So what we call this again is putting an ionic compound into solution and the ions dissociate. All right. Now, as we showed, molecular compounds can dissolve as well, but they don't dissociate, right? So if I have a compound like CH4, right, it might dissolve in water a little bit, and so we would call it AQ. We could say aqueous, it's dissolved in water, but it's not an ionic compound. So, you know, if we just showed this reaction or this process, CH4 gas dissolving into water, right? The CH4 is not an ionic compound, so it's not going to dissociate to any degree. Okay, so molecular compounds will dissolve sometimes, but they won't necessarily dissociate. Okay, and another way that you can tell that ions are in the solution is because the resulting solution will be conductive. Remember we talked about conductivity before? The conductive solutions will allow the light bulb to light up. Another name for conductive solutions is electrolytes. An electrolyte is a name of a solution that has ions in it, ions dissolved in it. A strong electrolyte means that you put the salt into the solution and it completely dissociates. A weak electrolyte means it only a little bit, and a non-electrolyte, this would be an example of a non-electrolyte compound you put into water and it dissolves but doesn't dissociate. There's no ions. This would be an example of a strong electrolyte. You put that into solution, sodium chloride, and you get sodium ions and chloride ions. Complete dissociation. That's how you know it's a strong electrolyte. Okay. So, we did these ones here. Now we're moving on to this. So, take a look at this one. See if you can figure out which ones would produce the chloride ion when dissolved in water and which ones would not. Okay? Take a look at it. Push pause. Look at it for a while. Try to figure out why some of these might or might not result in the chloride ion. Okay, I'm going to tell you now. So if you haven't got the answer yet, push pause until you get it. Okay, so we wouldn't expect the first one to produce chloride ion because PCl3 is not an ionic compound. Ionic compounds are the only ones that can ionize to form chloride ion, for example, or any ions for that matter. Okay, so on we go. How many ions will result in if we put this into water and it dissociates? This compound, sodium phosphate, how many ions will result when we put it into solution and dissociate? See if you can answer the question. Take a second. All right, after you're done, go ahead and push play again, but pause it for now and get the answer. All right, so I can look at this and I can see Na3PO4. I can see there's two types of ions, right? I have the sodium ion and I have the PO4 ion. I can look on my chart and I see that PO4 is a -3 ion. Sodium is a +1. I can look at the periodic table and see that. Okay, so to do this correctly, I can also remember that there's 3 sodium ions for every 1 phosphate ion. And that is how I can count up the total number of ions. So for each one of these that goes in, I get 3 plus 1. It's a total of 4 ions. So when this dissociates, I'm going to get 4 ions. All right, the next one, aluminum sulfate. Can you find out how many ions form upon the dissociation here? Take a second. Push pause, answer the question, and then come back. All right, I can see that aluminum sulfate is going to result in 2 of these aluminum ions and 3 of the sulfate ions. I look at the back of the periodic table and see the charge on that sulfate ion. That's a total of 5 ions. Very good. So, when we have a chemical equation that has the interaction of 2 ionic compounds that are dissolved in water, right, then the products will often be, one of them will be a solid, okay, or form what we call a precipitate.